Hello there, this is my solution to the design project for instrumentation and measurement, an Arduino-based ultrasonic obstacle avoidance input system for robots. My name is Michael, and let's get started. So this is just a quick run through of the components used and the setup of these components. For the microcontroller, I'm using the Romeo BLE Mini, and running off this I have the HC-SRO4 ultrasonic sensor, and beneath that the Tower Pro micro servo motor 9G. For the purpose of this demonstration, I have 3D printed a stand to attach the ultrasonic sensor to the servo motor for aesthetics and functionality. This microcontroller is useful in the fact that it has all of the digital and analog inputs sitting besides individual VCC and ground inputs, as you can see. Therefore, that actually reduces the need for a breadboard, meaning a far more compact system. As for wiring the ultrasonic sensor, the trig pin goes to the digital 2, and the echo pin runs to the digital 4. Its VCC and ground inputs are directly besides the other two pins, as you can see. The servo motor signal wire, the yellow wire, runs to digital 8, and again with its corresponding VCC and ground pins beside it. I tried to incorporate a LED into the system to indicate when the sensor detects an object. However, I was unsuccessful in the coding to implement this into my design. What you would need to incorporate this idea is just 3 female-to-female jump wires, a 330 ohm resistor, your breadboard, and of course your LED. Okay, so let's start the demonstration. For the purpose of the demonstration, I'm using an online software in the program called Processing. This is referenced in my report. This program will show us what the robot will see, as well as tell us the information that the robot will read, such as the distance that you will see in the bottom right. Again, only for visual representation and would likely not be used in its intended application. I have a ruler in place as proof of correct measurement for the sensor to show it's within its accuracy range. So let's plug it in. And we'll hit run. So as you can see, the sensor is currently detecting nothing, as I have set its maximum range to 40 centimeters. This is easily changeable within the program. It can go up to 4 meters. When we put an object in the sensor's field of view, again changeable in the program, it will detect the presence of this object. So I'm going to use this case. I'm going to put it at about 24 centimeters. And as you can see, it marks the object as red, and then the centimeters will appear in the bottom corner over there. There is a fluctuation as the surface I'm using is shiny, and it doesn't entirely like shiny surfaces. We can move the object closer to about 17 centimeters. Which would indicate the robot has moved closer to the incoming object in its path, or we can add multiple objects to its field of view. And as you can see, it detects that gap in between, which hopefully the robot would detect and be able to pass through. If I successfully implemented the LED, it would illuminate each time the sensor detects the object, which for demonstration purposes would represent the robot making a change or movement in decision, or movement or decision to avoid the obstacle in its path. So with that concludes the demonstration of the Ultrasonics Obstacle-avoidance input system for instrumentation and measurement from engineering student Michael Elway.